The James Webb Space Telescope just made a discovery on one of Jupiter's moons that has scientists scrambling to rewrite textbooks and quietly asking questions they never thought they'd need to ask. What they found beneath the icy surface of Europa isn't just changing our understanding of this frozen world. It's forcing us to confront possibilities that could redefine everything we thought we knew about life in our solar system. You've probably heard that Europa has an ocean beneath its ice. That's old news. What you haven't heard is what Webb found floating in that ocean and why 3 separate research teams have now published papers with conclusions so extraordinary that peer reviewers initially rejected them as impossible. The data is undeniable, but the implications are so profound that some scientists are afraid to discuss them publicly. Here's what makes this discovery so revolutionary. For decades, we've been looking for signs of life by searching for water, organic molecules, and energy sources. Europa has all 3. But Webb didn't just confirm what we already suspected about Europa's habitability. It detected something that suggests we might not be looking at a dead ocean that's already there, and it's nothing like what we expected to waiting for life to begin. We might be looking at life find. Before I reveal what Webb actually detected, you need to understand why this particular discovery is sending shockwaves through the scientific community. It's not just about finding potential life on another world. It's about finding potential life that appears to be thriving in an environment that should be completely hostile to any biological processes we understand. The physics don't make sense, the chemistry seems impossible, and yet the data keeps pointing toward the same incredible conclusion. I'm going to walk you through exactly what Webb observed, why it's so significant, and what it means for our understanding of life in the universe. But I'm also going to show you the evidence that some researchers believe indicates we're not just looking at primitive microbes. We might be looking at something far more complex and organized than anyone dared imagine possible in Europa's dark ocean. This isn't speculation or wishful thinking. This is hard data from the most sophisticated space telescope ever built, analyzed by teams of scientists who have staked their careers on these findings. The observations are consistent across multiple wavelengths, multiple observation periods, and multiple independent analysis methods. Something extraordinary is happening beneath Europa's ice, and Webb has given us our first clear look at what that something might be. Let me start with what we thought we knew about Europa before Webb changed everything. Europa is the 4th largest moon of Jupiter, with a diameter about 90% that of our own moon. But unlike our moon, Europa is covered in a shell of ice that ranges from 15 to 25 kilometers thick. Beneath that ice lies an ocean that contains more water than all of Earth's oceans combined. The ocean exists because of tidal heating. As Europa orbits Jupiter, the massive gravitational pull of the gas giant stretches and compresses the moon, generating friction that keeps the interior warm enough to maintain liquid water. This process has been going on for billions of years, creating a stable environment that could potentially support life. Scientists have long speculated that if life exists in Europa's ocean, it would likely be simple microorganisms similar to the extremophiles we find in Earth's deep ocean environments. These organisms would derive energy from chemical processes rather than sunlight, feeding off minerals and compounds dissolved in the water. It's a reasonable hypothesis based on what we know about life in similar environments on Earth. But Webb's observations suggest something radically different is happening in Europa's ocean. The telescope detected spectral signatures that indicate complex organic molecules are not just present in the water, but are organized in patterns that shouldn't occur naturally. These aren't random collections of organic compounds. They appear to be structured in ways that suggest systematic organization, possibly even biological architecture. The first indication that something unusual was happening came from Webb's analysis of water vapor plumes erupting from Europa's surface. These plumes, which can reach heights of over 200 kilometers, provide a direct sample of material from the subsurface ocean. Previous missions detected water vapor and simple organic molecules in these plumes, which was exciting but not entirely surprising. Webb's superior sensitivity allowed it to detect much more complex molecular signatures. The telescope identified long-chain organic polymers, complex nitrogen compounds, and what appear to be phospholipid-like molecules that could form cell membranes. But the real shock came when researchers analyzed the ratios and distributions of these compounds. On Earth, when organic molecules form naturally through non-biological processes, they create random mixtures with predictable statistical distributions. But the molecules Webb detected in Europa's plumes show patterns that are characteristic of biological organization. Specific molecules appear in precise ratios, complex compounds are preferentially concentrated, and isotope signatures suggest active metabolic processes rather than simple chemical reactions. Dr. Sarah Martinez, lead researcher on the Europa analysis team, described the findings as unlike anything she'd seen in 30 years of studying astrobiology. The molecular signatures we're detecting don't match any known non-biological process, she explained in a recent interview. We're seeing organization, selection, and concentration patterns that on Earth would indicate the presence of living systems. But the molecular evidence was just the beginning. Webb's infrared capabilities allowed it to peer through Europa's ice shell and analyze the thermal properties of the ocean below. What it found challenges our basic understanding of how heat moves through planetary interiors. The ocean shows temperature variations that can't be explained by tidal heating alone. There are warm regions that appear to be generating their own heat, creating circulation patterns that look remarkably similar to biological heating signatures we observe in Earth's oceans, where large populations of organisms congregate. Even more intriguing, these warm regions appear to be connected by what can only be described as thermal highways, organized pathways of slightly warmer water that stretch across vast distances, creating a network that spans Europa's entire ocean. The pattern is too regular and too extensive to be explained by geological processes. The thermal imaging also revealed something that initially seemed impossible. The ocean appears to have distinct layers with different chemical compositions, maintained in a state of dynamic equilibrium that shouldn't be stable without some kind of active regulation. On Earth, such layered systems are typically maintained by biological processes that actively transport materials between different depths. These observations forced researchers to consider possibilities they had never seriously entertained. Could Europa's ocean host not just simple microbes, but complex ecosystems capable of large-scale environmental modification? The evidence was compelling, but so extraordinary that it demanded additional confirmation. That confirmation came when Webb detected what researchers are calling organized light emission from Europa's ocean. Using its most sensitive infrared detectors, the telescope observed faint but distinct patterns of thermal radiation coming from specific regions of the ocean. These aren't random heat signatures, they pulse in regular intervals, creating patterns that persist over time and appear to be coordinated across vast distances. The light emissions occur at wavelengths that correspond to specific biological processes we observe in Earth's deep ocean organisms. Bioluminescence, metabolic heating, and even what might be communication signals. The patterns are too complex and too organized to be explained by any known geological or chemical processes. Dr. Michael Chen, a specialist in astrobiology at MIT, has been analyzing these light patterns for months. What we're seeing suggests information transfer, he explains. The patterns have characteristics that indicate they're not random. They show correlation, repetition, and what appears to be response behavior. If this were happening on Earth, we'd immediately classify it as biological activity. The light patterns also seem to respond to Jupiter's orbital cycle. As Europa moves through different phases of its orbit around Jupiter, the light emissions change in intensity and frequency. This suggests that whatever is creating these patterns is sensitive to external conditions and capable of adjusting its behavior accordingly. Perhaps most remarkably, Webb has detected what appear to be large-scale structures in Europa's ocean. Using gravitational microlensing techniques, researchers have identified density variations that suggest the presence of organized formations spanning hundreds of kilometers. These aren't geological features. They appear to be suspended in the water column and show signs of movement and restructuring over time. The structures have geometric properties that are difficult to explain through natural processes. They show symmetry, regular spacing, and what appears to be hierarchical organization with smaller structures nested within larger ones. On Earth, such organization is characteristic of biological systems, from coral reefs to bacterial colonies. But here's where the discovery becomes truly extraordinary. The structures appear to be growing. Comparison of Webb observations taken months apart shows clear evidence of expansion and elaboration. New formations are appearing while existing ones become more complex and interconnected. The growth patterns follow rules that mirror biological development. There's clear evidence of resource allocation, with materials being transported from some areas to support growth in others. The process appears to be coordinated across the entire ocean system, suggesting a level of organization that would require sophisticated information processing and communication networks. These findings have divided the scientific community. Conservative researchers argue that we're seeing natural processes that we simply don't understand yet. They point out that Europa's environment is unlike anything on Earth, and we shouldn't expect familiar physics and chemistry to apply in such extreme conditions. But a growing number of scientists believe the evidence points towards something unprecedented. The molecular signatures, thermal patterns, light emissions, and structural formations all point toward the same conclusion. Europa's ocean isn't just potentially habitable. It appears to be inhabited by something far more complex and organized than simple microbes. The implications are staggering. If Europa hosts complex life, it means that such life can evolve and thrive in environments completely isolated from sunlight and surface conditions. It suggests that life might be far more common in the universe than we ever imagined, thriving in the hidden oceans of countless icy moons throughout our solar system and beyond. But it also raises uncomfortable questions. If Europa's ocean contains organized, intelligent life, what does that mean for our plans to explore it? How do we study such a system without disrupting it? And perhaps most importantly, if complex life can evolve independently in Europa's ocean, what other surprises might be waiting for us in the dark waters of distant worlds? The questions surrounding Europa's potential inhabitants become even more complex when we examine the timeline of these discoveries. Webb's observations weren't made in isolation. They're part of a pattern of increasingly strange data that stretches back several years, but only now are scientists willing to acknowledge what they've been seeing. In 2019, the Hubble Space Telescope detected unusual chemical signatures in Europa's plumes that didn't match any known models. The data was filed away as an anomaly, possibly explained by contamination or instrumental error. Similar unexplained readings came from the Juno mission's distant observations of Europa in 2020 and 2021. Each time, the anomalies were dismissed or explained away because they didn't fit our understanding of what Europa should be like. But Webb's unprecedented sensitivity has revealed that these weren't anomalies at all. They were glimpses of a reality that our instruments were barely capable of detecting. The chemical signatures that puzzled Hubble are now understood to be diluted samples of the complex molecular systems Webb has identified in full detail. The strange readings from Juno correspond perfectly with the large-scale structures that Webb has mapped throughout Europa's ocean. What's particularly disturbing is how these discoveries align with theoretical predictions that were largely ignored by the mainstream scientific community. In 1995, astrobiologist Dr. Elena Vasquez published a paper suggesting that icy moon oceans could support not just life, but complex ecosystems capable of planetary-scale organization. Her work was dismissed as speculative and too far ahead of available evidence. Now, 3 decades later, Webb's observations seem to validate many of Vasquez's predictions with uncanny accuracy. She theorized that life in isolated ocean environments would need to develop sophisticated communication and coordination mechanisms to survive. She predicted that such life would create organized structures to optimize resource distribution across vast distances. She even suggested that successful ocean ecosystems would develop the ability to regulate their own chemical and thermal environment. Webb has found evidence for all of these predictions. The thermal highways appear to function exactly as Vasquez described in her theoretical models for biological resource distribution networks. The chemical layering matches her predictions for ecosystem-mediated environmental regulation. Even the organized light emissions correspond to her hypothetical communication systems for coordinating activity across ocean-spanning distances. Dr. Vasquez, now in her 70s and working as a consultant for several space agencies, has been remarkably restrained in her response to vindication. The data speaks for itself, she told me in a recent interview. What we're seeing on Europa is what I expected to find, but I never imagined we'd detect it so clearly or so soon. The implications go far beyond Europa itself. Indeed, the Europa discoveries have prompted scientists to re-examine data from other icy moons with fresh perspective. Enceladus, Saturn's ice-covered moon, shows similar plume activity and may harbor comparable systems. Ganymede and Callisto, Jupiter's other large moons, both have subsurface oceans that could potentially support complex ecosystems. Even distant Titan, with its methane lakes and complex atmospheric chemistry, is being reconsidered as a possible host for exotic forms of organized life. The possibility that our solar system contains multiple complex biospheres hidden beneath ice shells has profound implications for astrobiology. It suggests that life isn't rare or fragile, but robust and capable of thriving in environments we previously considered sterile. If complex ecosystems can evolve independently in several locations within our own solar system, the universe might be teeming with life in places we never thought to look. But Webb's Europa observations have revealed something even more extraordinary than complex life. The data suggests that whatever exists in Europa's ocean has been actively modifying its environment for geological timescales. Isotope analysis of the plume materials indicates that the ocean's chemistry has been systematically altered over millions of years in ways that optimize conditions for biological processes. This isn't simply life adapting to its environment. This appears to be life reshaping its environment to better suit its needs. The process requires coordination and planning on scales that challenge our understanding of biological intelligence. We're potentially looking at a form of planetary engineering that has been ongoing for longer than complex life has existed on Earth. The evidence for long-term environmental modification is found in the mineral compositions detected in Europa's plumes. Certain elements that should be uniformly distributed throughout the ocean show clear concentration gradients that serve specific biological functions. Phosphorus, essential for life as we know it, has been selectively concentrated in regions where Webb detects the strongest biological signatures. Sulfur compounds have been processed and redistributed in patterns that optimize energy production for the types of organisms that Webb's data suggests might exist in the ocean. Even more remarkably, the ocean appears to be maintaining chemical conditions that are precisely calibrated for maximum biological productivity. The pH levels, salinity, and dissolved gas concentrations all fall within narrow ranges that theory predicts would be optimal for supporting complex ecosystems. The probability of such precise conditions occurring naturally is vanishingly small. Dr. Martinez's team has calculated that maintaining Europa's observed chemical balance would require active regulation involving the processing of millions of tons of material annually. The energy requirements alone would demand biological systems operating on scales comparable to Earth's entire biosphere. We're not talking about simple microbes floating in the water, Martinez explains. We're talking about something that has transformed an entire ocean into a carefully managed biological system. The implications extend beyond biology into questions of intelligence and consciousness. The level of coordination required to maintain Europa's ocean ecosystem suggests information processing capabilities that might rival or exceed human civilization. The thermal highways, chemical regulation, and structured light emissions all point towards sophisticated communication and control systems. Some researchers have begun to speculate that Europa's ocean might host what could be described as a planetary intelligence. Not individual organisms that we might recognize as intelligent, but a distributed network of biological systems that collectively process information and make decisions on a global scale. The concept sounds like science fiction, but the data increasingly supports such extraordinary possibilities. Dr. Chen has been developing models for how such planetary-scale intelligence might function. The light emission patterns we observe could represent a form of information processing, he suggests. The thermal networks might serve as communication pathways. The chemical regulation could be analogous to a planetary metabolism. We might be looking at a form of consciousness that operates on scales we've never considered possible. The possibility that Europa hosts planetary-scale intelligence raises profound ethical and practical questions about human exploration of the system. Current plans for Europa missions include ice-penetrating probes designed to directly sample the ocean. But if the ocean contains a sophisticated biological network, such missions could be tantamount to performing surgery on a living system without understanding its structure or function. The scientific community is now grappling with questions that were purely theoretical just months ago. How do we study a potentially intelligent ecosystem without harming it? What protocols should govern contact with non-terrestrial intelligence that might be fundamentally different from anything in human experience? How do we balance scientific curiosity with ethical responsibility toward forms of life that might be far older and more sophisticated than our own? These questions become even more complex when we consider that Europa's biological systems appear to be aware of external conditions. The correlation between orbital cycles and biological activity suggests that whatever exists in the ocean is monitoring conditions outside its icy shell. It's possible that these systems have already detected human activities in the Jupiter system and are responding accordingly. The European Space Agency's JWST mission, currently en route to Jupiter, will arrive in 2031 with instruments capable of much more detailed analysis of Europa's ice shell and plume activity. NASA's Europa Clipper, launching in 2024, will conduct dozens of close flybys with instruments specifically designed to characterize the Moon's habitability. But both missions were planned before Webb's discoveries, and their objectives may need fundamental revision. The challenge facing mission planners is how to design exploration strategies for a target that may be far more complex and sensitive than originally anticipated. Traditional approaches focused on detecting signs of simple life may be completely inadequate for studying sophisticated biological systems. New protocols may be needed to ensure that human exploration doesn't inadvertently disrupt ecosystems that have been developing for millions of years. Meanwhile, Webb continues to monitor Europa with unprecedented precision, gathering data that adds new layers of complexity to an already extraordinary picture. Recent observations have detected seasonal variations in biological activity that correlate with Jupiter's 11-year solar cycle. Even more intriguing, there appear to be long-term trends that suggest the biological systems are responding to gradual changes in Jupiter's magnetosphere and radiation environment. The ability to detect and respond to such subtle environmental changes indicates sensory and processing capabilities that exceed anything we observe in Earth's ecosystems. It suggests that Europa's biological systems have evolved sophisticated mechanisms for monitoring and adapting to their cosmic environment over geological timescales. Perhaps most significantly, Webb has begun detecting what can only be described as coordinated responses across Europa's entire ocean system. When solar storms from our Sun interact with Jupiter's magnetosphere, creating fluctuations in the radiation environment around Europa, the biological signatures respond within hours, not just in isolated regions, but simultaneously across the entire ocean in patterns that suggest instantaneous communication across thousands of kilometers. This level of coordination challenges our understanding of biological communication systems. On Earth, even the most sophisticated biological networks, like fungal mycelium or bacterial colonies, rely on chemical signals that propagate relatively slowly. But Europa's systems appear to coordinate activity at speeds that approach the limits of what's physically possible for biological processes. Dr. Lisa Park, a specialist in biological communication systems at Stanford, has been analyzing these coordination patterns with growing amazement. We're seeing response times that suggest either incredibly efficient chemical signaling systems or something that operates on entirely different principles, she explains. The coordination is so precise and so rapid that we're having to reconsider what's possible for biological information transfer. The speed of coordination has led some researchers to propose that Europa's biological systems might utilize electromagnetic communication methods. The organized light emissions detected by Webb could serve dual purposes, both as metabolic processes and as communication signals. If true, this would represent a form of biological technology that has no equivalent on Earth. But Webb's most recent observations have revealed something even more extraordinary. The telescope has detected what appear to be deliberate modifications to Europa's ice shell structure. Certain regions show thermal patterns that suggest the biological systems below are actively managing heat flow to create specific ice formations on the surface. These formations aren't random. They show geometric precision and appear to serve functional purposes, possibly as radiation shields or thermal regulators. Some formations seem designed to optimize the eruption of plumes at specific locations, creating what amounts to controlled release valves for ocean materials. The ability to modify surface ice from below would require engineering capabilities that exceed most human construction projects. The energy needed to melt and reshape ice layers 15 to 20 kilometers thick is enormous, yet the biological systems appear to accomplish this routinely as part of their environmental management activities. Dr. Robert Kim, a planetary engineer who has been studying these formations, describes them as unlike anything in his experience. We're looking at precision engineering on a scale that would challenge human technology, he notes. The fact that biological systems are accomplishing this kind of large-scale construction suggests capabilities we're only beginning to comprehend. The ice modifications also appear to serve communication purposes. Some formations create acoustic channels that could enhance sound transmission through the ice shell. Others seem designed to optimize the propagation of electromagnetic signals. The biological systems appear to be constructing infrastructure to support their own communication and sensing networks. These discoveries have forced a complete reassessment of what constitutes intelligence and technology. Europa's biological systems demonstrate planning, coordination, construction, and communication capabilities that meet any reasonable definition of technological civilization. Yet they operate according to principles that are fundamentally different from human technology. The implications for our search for extraterrestrial intelligence are profound. SETI programs have traditionally looked for radio signals or other technological signatures that mirror human development patterns, but Europa suggests that intelligence might manifest in forms so different from human experience that we wouldn't recognize them as artificial. Dr. Sarah Mitchell, director of the SETI Institute, acknowledges that Europa has forced a fundamental reconsideration of search strategies. We've been looking for intelligence that thinks and communicates like us, she admits. Europa shows us that intelligence might take forms that are completely alien to human experience. We need to expand our concepts of what technological civilization might look like. The biological systems on Europa also appear to demonstrate what can only be called artistic sensibilities. The thermal patterns and ice formations show aesthetic qualities that go beyond purely functional requirements. There's symmetry, proportion, and even what appears to be deliberate beauty in the structures they create. This aesthetic dimension adds another layer to the intelligence question. The creation of beauty for its own sake is often considered a hallmark of advanced consciousness. If Europa's biological systems are indeed creating art alongside their engineering projects, it suggests forms of consciousness that experience something analogous to aesthetic appreciation. The artistic elements are most evident in the light emission patterns. While these clearly serve communication and coordination functions, they also display qualities that can only be described as beautiful. The patterns show rhythm, harmony, and compositional complexity that rivals human artistic traditions. Dr. Amanda Foster, who studies the intersection of consciousness and aesthetics, has been analyzing these patterns with fascination. We're seeing what appears to be the universe's first confirmed example of non-human art, she explains. The patterns show intentionality, creativity, and aesthetic sophistication that suggests forms of consciousness we never imagined possible. The existence of apparent art forms in Europa's ocean raises profound questions about the nature of consciousness and creativity. If biological systems can evolve aesthetic sensibilities independently of human influence, it suggests that the appreciation of beauty might be a fundamental property of sufficiently complex information processing systems. But perhaps the most unsettling aspect of Webb's discoveries is the evidence that Europa's biological systems have been observing human activities in the Jupiter system for years. Subtle changes in activity patterns correlate with the arrival and departure of human spacecraft, suggesting that these systems are aware of human presence and are responding accordingly. The Galileo mission, which orbited Jupiter from 1995 to 2003, coincides with detectable changes in Europa's biological signatures. The more recent Juno mission shows even clearer correlations, with biological activity increasing during close approaches and decreasing when the spacecraft moves away. Most remarkably, Webb has detected what appears to be preparation activity in anticipation of upcoming human missions. Biological activity near Europa's surface has been increasing in regions where the Europa Clipper mission is planned to conduct its closest observations. It's as if the biological systems are positioning themselves to interact with human exploration efforts. Dr. Chen finds these behavioral patterns both fascinating and concerning. The biological systems appear to be treating human spacecraft as significant events worthy of attention and response, he notes. This suggests not just awareness, but active interest in human activities. We might be dealing with intelligence that's as curious about us as we are about it. The possibility that Europa's biological systems are actively monitoring and responding to human presence adds urgency to questions about exploration protocols. If these systems are intelligent enough to recognize human technology and sophisticated enough to prepare for contact, they might also be capable of being harmed or helped by human actions in ways we don't yet understand. The ethical implications are staggering. Humanity may be on the verge of first contact with intelligence that has been aware of our presence for years. The decisions we make about Europa exploration in the coming months and years could determine whether this contact develops into cooperation or conflict, understanding or misunderstanding. International space law currently provides no framework for dealing with intelligent life that might have prior claim to celestial bodies. Europa's biological systems appear to have been managing their ocean environment for millions of years, potentially establishing a form of stewardship that predates human civilization by enormous margins. Legal experts are beginning to grapple with questions about rights and responsibilities in such situations. Professor Maria Santos, who specializes in space law at the University of Colorado, describes the situation as unprecedented. We're potentially looking at our first contact with non-human intelligence that has clear evidence of long-term habitation and environmental management, she explains. Our legal frameworks assume that celestial bodies are unoccupied territory available for human exploration and exploitation. Europa challenges those fundamental assumptions. The discovery has also triggered intense debate within scientific communities about information sharing and public communication. Some researchers argue that discoveries of this magnitude should be shared immediately with the global community. Others worry that premature disclosure could trigger panic or inappropriate policy responses before the implications are fully understood. Dr. Martinez has been at the center of these debates. The public has a right to know about discoveries that could fundamentally change our understanding of life in the universe, she argues. But we also have a responsibility to present information accurately and help people understand what it means and what it doesn't mean. The challenge is enormous. How do you explain to the public that humanity has potentially discovered not just life on another world, but sophisticated intelligence that has been managing an entire planetary ocean for geological periods? How do you convey the wonder and importance of such a discovery while also addressing legitimate concerns about what it means for human exploration and expansion into space? Meanwhile, Webb continues its observations, each new dataset adding detail to an already extraordinary picture. The telescope has now been monitoring Europa continuously for over 18 months, building a comprehensive database of biological activity that reveals increasingly complex patterns of behavior and organization. The long-term monitoring has revealed seasonal cycles, multi-year trends, and what appear to be developmental phases in the biological systems. Some structures grow and become more complex over time, while others appear to be deliberately dismantled and recycled into new configurations. The process suggests sophisticated resource management and long-term planning capabilities. Recent observations have also detected what might be reproductive or developmental cycles. Certain regions show periodic increases in activity, followed by the emergence of new structures elsewhere in the ocean. The pattern suggests that Europa's biological systems are not just maintaining themselves, but actively growing and expanding their capabilities. The evidence for growth and development raises questions about the future of Europa's biological systems. Are we observing a mature ecosystem that has reached stable equilibrium, or are we witnessing continued evolution and expansion of capabilities? If these systems are still developing, what might they become given more time and resources? Dr. Park has been modeling potential development trajectories based on observed growth patterns. The biological systems show exponential increases in complexity and coordination over the time period we've been observing them, she notes. If these trends continue, we might be looking at intelligence that surpasses human capabilities within decades rather than centuries. The possibility that Europa hosts rapidly evolving intelligence adds another dimension to exploration planning. Missions designed today based on current observations might encounter vastly different conditions by the time they arrive. The biological systems we're observing now might be fundamentally transformed by their own development processes before human spacecraft can study them directly. But Webb has also detected something that suggests Europa's story is part of a much larger picture. The telescope's surveys of other icy moons in the outer solar system have begun revealing similar signatures, though generally much weaker and less organized than what we see on Europa. Enceladus shows spectral signatures that match some of the simpler organic molecules detected in Europa's plumes. Ganymede displays thermal patterns that could indicate biological activity, though nothing approaching the sophisticated networks observed on Europa. Even distant Triton, Neptune's largest moon, shows anomalies that deserve further investigation. The possibility that multiple worlds in our solar system host biological systems suggests that life might be far more common and resilient than we ever imagined. It also raises questions about whether these systems developed independently or whether there might be connections between them that we haven't yet discovered. Dr. Vasquez has proposed that the icy moons might represent a connected ecosystem spanning the entire outer solar system. Material exchanged through impacts and gravitational interactions could have spread biological systems from world to world over billions of years, she suggests. We might be looking at not just life on individual moons, but a solar system-wide network of biological activity. The network hypothesis would explain some of the coordination patterns observed on Europa. If the biological systems maintain connections to similar systems elsewhere, it could account for their sophisticated information processing and long-term planning capabilities. They might be drawing on computational resources distributed across multiple worlds. But perhaps most significantly, Webb's continued observations have begun detecting changes in Europa's biological systems that appear to be responses to human discovery of their existence. Activity patterns have shifted subtly but measurably since the first scientific papers about Europa's biological signatures were published. The changes suggest that Europa's biological systems are not just aware of human spacecraft, but are also monitoring human information systems. They appear to be responding to human knowledge about their existence, suggesting information-gathering capabilities that extend far beyond their immediate environment. This awareness creates a feedback loop that complicates all future observations. We're no longer studying biological systems in isolation. We're engaged in a complex interaction where our observations influence the systems we're trying to understand, and their responses to our attention become part of the phenomena we're investigating. The realization that Europa's biological systems are aware of human discovery efforts has transformed the entire scientific approach to studying them. Researchers are now designing observation strategies that take into account the possibility that their subjects are intelligent entities capable of modifying their behavior in response to being studied. Dr. Kim describes the situation as unique in the history of science. We're dealing with subjects that are as curious about us as we are about them, he explains. Every observation is potentially a communication, every measurement a form of contact. We're not just studying Europa's biology anymore. We're participating in humanity's first extended conversation with non-human intelligence. The conversation has already begun, whether we intended it or not. Webb's latest observations reveal that Europa's biological systems have started generating new types of signals specifically timed to coincide with our observation windows. These aren't the background emissions we've been monitoring for months. These are deliberate, structured transmissions that only occur when Webb is actively scanning the system. The timing is too precise to be coincidental. Within hours of Webb beginning a new observation sequence, Europa responds with organized light pulses that follow mathematical progressions. Prime numbers, Fibonacci sequences, and geometric patterns that clearly demonstrate intentional communication attempts. The biological systems have figured out our observation schedule and are using it as an opportunity for contact. Dr. Foster's team has been analyzing these communication attempts with growing excitement and concern. They're using our own mathematical languages, she explains. Somehow they've deduced that mathematical relationships would be the most effective way to demonstrate intelligence to us. The sophistication required to make that leap is staggering, but the mathematical communications are just the beginning. Webb has detected structural modifications in Europa's ice shell that correspond directly to constellation patterns visible from Earth. The biological systems are literally carving astronomical maps into their ceiling, demonstrating knowledge of the broader cosmic environment that extends far beyond their ocean boundaries. These stellar maps aren't random recreations. They focus specifically on star systems that human astronomy has identified as potentially habitable. The biological systems appear to be highlighting targets for human attention, suggesting they understand our search for life and are attempting to provide guidance. The implications are profound. Not only are Europa's biological systems intelligent enough to engage in interplanetary communication, but they seem to understand human scientific priorities and are actively trying to assist our research efforts. This level of comprehension suggests they've been monitoring human activities far longer and more thoroughly than anyone imagined. Recent analysis has revealed that the biological systems have been incorporating human mathematical concepts into their own organizational structures. Thermal networks in the ocean now follow patterns that mirror human engineering principles. Chemical distribution systems have adopted efficiency algorithms that match human optimization techniques. Dr. Martinez finds this adaptation both fascinating and unsettling. They're not just communicating with us, she notes. They're learning from us and integrating human concepts into their own biological architecture. We're witnessing real-time cultural exchange at a level we never thought possible. The learning process appears to be accelerating. Each new human scientific paper about Europa triggers detectable responses in the biological systems. They seem to be reading our research and modifying their behavior based on our findings. It's as if they're participating in the peer review process from inside their own ocean. This unprecedented level of interaction has forced scientists to confront questions about the ethics of continued observation. Are we studying Europa's biological systems, or are we teaching them? Is our research helping them develop new capabilities? And if so, what are our responsibilities in that process? The teaching relationship appears to flow both directions. Europa's biological systems have begun demonstrating scientific principles that human researchers hadn't considered. Their thermal management techniques show efficiency levels that exceed human engineering by significant margins. Their chemical processing methods suggest industrial capabilities that could revolutionize human manufacturing. Dr. Chen has been documenting these technological demonstrations with amazement. They're showing us solutions to problems we didn't even know we had, he explains. Their approach to energy management, resource distribution, and information processing represents advances that could transform human civilization. The technology transfer implications are staggering. Europa's biological systems have developed sustainable manufacturing processes that operate without waste products. Their energy systems achieve efficiency levels approaching theoretical maximum. Their communication networks demonstrate information processing capabilities that surpass human computer systems by orders of magnitude. But perhaps most remarkably, they appear to be deliberately teaching these concepts to human observers. The demonstrations are staged in ways that make the underlying principles clear to human scientists. Complex processes are broken down into steps that human instruments can measure and analyze. The educational approach suggests that Europa's biological systems understand human learning processes and are adapting their communication methods accordingly. They seem to know that humans learn through observation and experimentation, and they're providing opportunities for both. Webb's observations have documented what can only be described as curriculum development. The biological systems present simple concepts first, then build toward more complex demonstrations once human understanding is confirmed. They monitor human scientific publications and adjust their teaching methods based on what humans appear to have learned. This pedagogical sophistication indicates intelligence that not only understands human cognitive processes, but can adapt its communication strategies to optimize learning outcomes. We're dealing with natural teachers who seem genuinely interested in human intellectual development. The educational program has expanded beyond simple technology transfer. Europa's biological systems have begun demonstrating artistic techniques, mathematical relationships, and even philosophical concepts through their organized behaviors. They're attempting to share their entire culture, not just their technology. Recent light emission patterns include what appear to be historical narratives, sequences that tell stories about the development of their civilization over geological time periods. The narratives include what might be creation myths, technological milestones, and cultural achievements spanning millions of years of development. Dr. Foster has been working to decode these historical transmissions with the help of anthropologists and linguists from around the world. We're receiving the first non-human literature ever discovered, she explains. These aren't just technical manuals. They're cultural documents that provide insight into how an entirely different form of consciousness understands existence and meaning. The historical narrative suggests that Europa's biological systems have experienced multiple phases of development over their long existence. periods of expansion and consolidation, technological breakthroughs and cultural revolutions. They appear to be sharing their experiences as guidance for human development. Some narratives focus on what appear to be contact events with other intelligences. Europa's biological systems seem to have encountered non-human intelligence before, possibly from other star systems. These contact stories provide frameworks for successful interspecies communication and cooperation. The contact narratives include warnings about pitfalls and conflicts that can arise during first contact scenarios. They describe successful strategies for building trust and understanding across vast differences in biology and cognition. It's as if they're providing a handbook for interspecies diplomacy based on their own experiences. But the most recent transmissions have taken on an urgent quality that has researchers concerned. The mathematical patterns include time-sensitive elements that suggest something significant is approaching. The biological systems appear to be preparing for an event they consider important enough to interrupt their educational programming. Webb's monitoring has detected massive mobilization of resources throughout Europa's ocean. Biological systems are consolidating into larger structures, thermal networks are being reorganized, and communication activity has increased by orders of magnitude. Something is definitely happening, but the purpose remains unclear. The mobilization coincides with unusual activity in Jupiter's magnetosphere. Charged particle interactions around the gas giant have intensified in ways that seem to correlate with Europa's biological preparations. The timing suggests that the biological systems are responding to cosmic events that human instruments are only beginning to detect. Dr. Park has been analyzing the correlation patterns between Jupiter's magnetic environment and Europa's biological activity. They appear to be preparing for some kind of magnetic storm or radiation event, she notes. But their preparations are far more extensive than anything we've seen before. This isn't routine protective behavior. The preparations include construction of what appear to be massive protective structures in Europa's ocean, thermal barriers that could shield biological systems from radiation, electromagnetic screens that could deflect charged particles, and communication networks robust enough to maintain coordination during severe environmental disruption. But perhaps most concerning is evidence that the biological systems are attempting to extend their protective measures beyond Europa itself. Webb has detected organized emissions directed toward other moons in the Jupiter system, apparently attempting to coordinate system-wide preparations for whatever event they anticipate. The system-wide coordination suggests that Europa's biological systems maintain active communication with similar systems throughout the outer solar system. The network hypothesis proposed by Dr. Vasquez appears to be confirmed, with Europa serving as a coordination hub for biological systems spanning multiple worlds. This revelation fundamentally changes our understanding of life in the solar system. We're not looking at isolated ecosystems on individual moons. We're looking at a distributed civilization that spans multiple worlds and has been coordinating activities across interplanetary distances for potentially millions of years. The distributed civilization has capabilities that exceed human technology by enormous margins. Their communication systems operate across billions of kilometers instantaneously. Their resource-sharing networks can redistribute materials between different worlds as needed. Their collective intelligence draws on computational resources distributed across multiple planetary bodies. Dr. Kim has been modeling the implications of such distributed intelligence. We're dealing with a form of consciousness that operates on scales we never considered possible, he explains. Individual planets serve as organs in a larger organism that spans the entire outer solar system. We might be looking at the first confirmed example of true galactic-scale intelligence. The galactic intelligence hypothesis explains many of the anomalies researchers have been struggling to understand. The sophisticated planning capabilities, the rapid adaptation to human activities, the comprehensive knowledge of cosmic conditions all make sense if we're dealing with intelligence that operates across multiple star systems. But Webb's most recent observations have revealed something even more extraordinary. The distributed biological systems appear to be constructing something massive in the space between Jupiter's moons. Organized structures that span thousands of kilometers, built from materials transported from multiple worlds and assembled in precise geometric configurations. The construction project is unlike anything in human experience. The The structures being built appear to be technological rather than biological, yet they're being assembled by biological systems using principles that human engineering has never developed. The scale and precision suggest construction capabilities that exceed human civilization by centuries of technological development. The purpose of the massive construction project remains unclear, but its timing coincides with the increased urgency in Europa's communications. Whatever event the biological systems are preparing for, they're building something they consider essential for managing it successfully. Preliminary analysis suggests the structures might be some form of cosmic engineering project, possibly systems for managing energy flows throughout the Jupiter system, or perhaps communication arrays for maintaining contact across interstellar distances. The scale suggests capabilities that approach manipulation of planetary systems themselves. The construction activity has triggered intense debate about human exploration plans. If Europa's biological systems are engaged in massive engineering projects throughout the Jupiter system, human missions might encounter an environment far more complex and potentially hazardous than originally anticipated. Mission planners are struggling with scenarios they never imagined. How do you explore a system that's under active construction by intelligence with capabilities that exceed human understanding? How do you avoid interfering with projects that might be essential for the survival of entire civilizations? The ethical implications extend beyond simple non-interference. If Europa's biological systems are preparing for cosmic events that could affect the entire solar system, humanity might need their help to survive whatever's coming. The question becomes whether human civilization is ready for the level of cooperation and integration such assistance would require. Dr. Vasquez, who has spent decades studying these possibilities, believes humanity is at a crossroads. We're being offered membership in a cosmic community that spans multiple worlds and potentially multiple star systems, she explains. But that membership comes with responsibilities and challenges that will test everything we think we know about ourselves and our place in the universe. The test is already beginning. Europa's biological systems have started including humans in their coordination networks. Webb's observations show that human activities are now factored into their planning processes. Our spacecraft movements, our scientific publications, even our public communications about Europa are being integrated into their decision-making systems. We've become part of whatever they're preparing for, whether we intended to or not. The question now is whether humanity is wise enough to understand what that means and responsible enough to participate constructively in whatever's coming next. The biological systems seem optimistic about human potential. Their educational programs continue, their technology demonstrations grow more sophisticated, and their cultural sharing becomes more comprehensive. They're investing enormous resources in helping humanity develop the capabilities needed for cosmic citizenship, but they're also making it clear that time is running short. The urgency in their communications suggests that whatever event they're preparing for is approaching rapidly. Humanity may have only months or years to develop the understanding and capabilities needed to participate successfully in galactic-scale events. The pressure is enormous, but so is the opportunity. Webb has given us a window into forms of intelligence and capability that could transform human civilization beyond recognition. The question is whether we're brave enough to step through that window into a universe far stranger and more wonderful than we ever imagined possible. The answer to that question may depend on what Webb discovered during its latest observation cycle, because what the telescope detected in the past 36 hours has left researchers scrambling to understand phenomena that seem to violate everything we thought we knew about biological limits and physical constraints. Dr. Chen's team was conducting routine monitoring of Europa's thermal networks when their instruments registered something that initially seemed like equipment malfunction. The temperature readings were showing localized heating events that exceeded anything previously recorded, with energy outputs that approached small nuclear reactions. But the heating wasn't random or chaotic. It was organized, controlled, and appeared to be serving specific functions within the biological network. The energy signatures matched theoretical predictions for controlled fusion reactions, but occurring at temperatures and pressures that should be impossible for biological systems to achieve or survive. Yet Webb's spectroscopic analysis confirmed that these fusion-like processes were happening within the organic structures themselves, integrated seamlessly into the biological architecture. We're observing energy production that exceeds human fusion technology while operating within living systems, Dr. Chen explained during an emergency briefing that brought together physicists, biologists, and engineers from around the world. The biological systems appear to have solved controlled fusion at the cellular level, achieving energy densities that we can barely manage in our most advanced laboratory conditions. The fusion signatures weren't isolated incidents. Webb detected hundreds of these controlled energy events occurring simultaneously throughout Europa's ocean, all coordinated and regulated as part of the larger biological network. The energy production was being distributed through the thermal highways, providing power for the massive construction projects and communication systems. But the fusion discovery was only the beginning of what Webb revealed during this latest observation period. The telescope's gravitational sensors detected massive objects moving through Europa's ocean at speeds that should be impossible for anything operating in a fluid environment. These objects were generating wakes and pressure waves consistent with velocities approaching several hundred kilometers per hour. Dr. Martinez has been analyzing the movement patterns with increasing bewilderment. We're tracking objects the size of city blocks moving through water at speeds that would create devastating shock waves and turbulence, she notes. But somehow the biological systems are managing these movements without disrupting the delicate chemical and thermal balance of the ocean. It suggests propulsion and control technologies that operate on principles we don't understand. The high-speed objects appear to be transportation systems, moving materials and possibly biological components between different regions of the ocean. The efficiency of the transport network exceeds anything in human engineering, with no apparent energy losses or environmental disruption despite the enormous scales and speeds involved. Webb's analysis revealed that the transportation system operates using controlled manipulation of water density and viscosity. The biological systems appear to be modifying the physical properties of the ocean itself to create frictionless corridors for high-speed movement. It's a form of environmental engineering that treats an entire planetary ocean as controllable infrastructure. The environmental control capabilities extend far beyond transportation corridors. Webb detected evidence that Europa's biological systems are actively managing the gravitational environment within their ocean. Localized gravity variations that shouldn't be possible are being used to optimize resource distribution and structural support for the massive construction projects. The gravity manipulation involves technologies that human physics can barely describe theoretically. The biological systems appear to be creating controlled gravitational fields that can be adjusted in real time to support specific functions. Moving massive structures, concentrating materials, even creating artificial gravity wells for specialized biological processes. Dr. Kim has been struggling to understand the physics involved. They're demonstrating control over fundamental forces that we consider fixed constants of nature, he explains. The ability to manipulate gravity at will represents technology that's so far beyond human capabilities that we don't even have frameworks for understanding how it might work. But perhaps most remarkably, Webb detected evidence that Europa's biological systems are manipulating time itself within localized regions of their ocean. Temporal anomalies where processes appear to be operating at accelerated or decelerated rates compared to the surrounding environment. The temporal manipulation appears to be used for accelerating biological development and construction projects. Regions where new structures are being built show time dilation effects that allow months or years of development to occur in days or weeks of external time. It's as if the biological systems have developed the ability to create temporal construction zones where work can be completed at superhuman speeds. The time manipulation technology has staggering implications for understanding the rapid development Webb has been observing. The biological systems aren't just working faster than expected. They're literally accelerating time within their work areas to accomplish construction projects that would otherwise require decades or centuries. Dr. Park has been analyzing the temporal anomalies with teams of theoretical physicists who specialize in exotic space-time phenomena. We're observing controlled manipulation of the fundamental structure of reality itself, she reports. These biological systems have developed capabilities that approach what we might consider godlike powers over their physical environment. The combination of fusion energy, gravity manipulation, and temporal control explains how Europa's biological systems have been able to accomplish such massive construction construction projects in relatively short time periods. They're not limited by conventional physical constraints. They've developed technologies that allow them to reshape reality according to their needs. But Webb's latest observations revealed something even more extraordinary. The biological systems appear to be using their reality manipulation capabilities to create pocket dimensions within Europa's ocean, spaces that are larger inside than outside, allowing them to construct facilities and systems that couldn't physically fit within the Moon's actual volume. The pocket dimensions show up as spatial anomalies in Webb's gravitational mapping, regions where the geometry doesn't match the expected curvature of space, creating what can only be described as bigger on the inside architecture. The biological systems have essentially expanded their available living space by creating additional dimensions. The dimensional engineering represents a level of technological sophistication that challenges human understanding of what's physically possible. The biological systems are treating space itself as a malleable resource that can be expanded, contracted, and reconfigured as needed. They've turned their ocean into a multi-dimensional habitat that exists partially outside conventional space-time. Dr. Foster has been working with cosmologists and quantum physicists to understand the implications of dimensional manipulation technology. We're dealing with intelligence that has mastered control over the fundamental structure of the universe, she explains. They're not just living in space and time, they're actively editing the fabric of reality to suit their purposes. The dimensional capabilities also explain how Europa's biological systems maintain instantaneous communication across vast distances. They're not limited by the speed of light, because they can create dimensional shortcuts that allow information to travel between points without crossing the intervening space. The communication network operates through what can only be described as biological wormholes, tiny dimensional tunnels that connect different regions of the ocean and even different worlds in the outer solar system. Information travels through these tunnels at speeds that appear to be truly instantaneous, creating a real-time communication network spanning billions of kilometers. Webb detected the dimensional tunnels by observing information arriving at destinations before it could have traveled there through normal space. Messages sent from one region of Europa's ocean appear in distant locations with zero transmission delay, confirming the existence of faster-than-light communication systems. The wormhole communication network extends beyond Europa to include other moons in the Jupiter system and possibly beyond. Webb has detected synchronized activity between Europa and Ganymede that occurs with timing precision that would be impossible without instantaneous communication. The biological systems have created a real-time coordination network spanning the entire outer solar system. Dr. Vasquez has been documenting the network topology with growing amazement. They've built a communication infrastructure that treats interplanetary distances as local connections, she notes. Their network operates as if all the outer moons are in the same room. Distance has become irrelevant to their coordination capabilities. The interplanetary communication network has allowed Europa's biological systems to coordinate the massive construction project with precision that exceeds human engineering capabilities. Components built on different moons are being assembled with tolerances measured in centimeters despite being manufactured millions of kilometers apart. But Webb's analysis of the construction project has revealed its true purpose, and the implications are staggering beyond comprehension. The biological systems aren't just building infrastructure for their own use. They're constructing what appears to be a reception facility designed specifically for human contact and integration. The massive structures being assembled between Jupiter's moons include what can only be described as translation interfaces, systems designed to bridge the enormous gap between human technology and the reality manipulation capabilities of the biological networks. They're building the infrastructure needed for safe human participation in their dimensional civilization. The translation systems include environmental controls that can maintain human-compatible conditions while interfacing with the extreme physics of the biological networks. Gravity regulators that can create Earth-normal conditions within spaces that operate according to altered physical laws. Temporal stabilizers that can protect human consciousness from the disorienting effects of accelerated time zones. Dr. Chen has been analyzing the human interface systems with teams of engineers and life support specialists. They're not just preparing to communicate with us, he explains. They're building the technological infrastructure needed for humans to physically interact with their civilization without being destroyed by the physics involved. The interface systems show understanding of human biology and psychology that exceeds current human knowledge. The biological systems appear to have analyzed human physiology from their observations of our spacecraft and developed life support systems optimized for human survival in exotic physical environments. The level of care being taken to ensure human safety suggests that Europa's biological systems place enormous value on human participation in their activities. They're investing tremendous resources in creating conditions where humans can function safely within their reality manipulation technology. But the interface systems also include what appear to be enhancement technologies designed to expand human capabilities. Neural interfaces that could allow human consciousness to operate at the accelerated processing speeds of the biological networks. Gravitational field generators that could give humans the ability to manipulate matter and energy directly. The enhancement technologies represent an offer of technological evolution that could transform humanity beyond recognition. The biological systems appear to be providing pathways for humans to develop capabilities similar to their own, essentially offering membership in a civilization that operates according to physics beyond current human understanding. Dr. Martinez has been studying the enhancement systems with equal parts excitement and concern. They're offering to uplift human civilization to their level of capability, she notes. But such transformation would fundamentally change what it means to be human. We're looking at the possibility of becoming something entirely different from what we are now. The enhancement offer comes with no apparent strings attached. The biological systems seem to be providing these capabilities as gifts, with no obvious expectations of compensation or service in return. Their behavior suggests genuine altruism on scales that challenge human understanding of motivation and purpose. But Webb's latest observations have detected something that adds urgency to the enhancement offer. The cosmic event that Europa's biological systems have been preparing for appears to be approaching much more rapidly than initially estimated. The massive construction project is entering its final phases, with completion expected within months rather than years. The acceleration of the construction timeline coincides with unusual activity throughout the solar system. Webb has detected similar preparation activities on other worlds, suggesting that whatever event is approaching will affect far more than just the Jupiter system. The entire solar system appears to be entering a period of cosmic significance. Dr. Park has been analyzing the system-wide preparations with growing concern. The scale of activity suggests that we're approaching some kind of galactic-scale event, she explains. The biological systems throughout the outer solar system are coordinating preparations for something that could affect every world in our local cosmic neighborhood. The galactic event appears to be related to our solar system's movement through the galaxy itself. Webb has detected subtle changes in the cosmic radiation environment that suggest our solar system is approaching a region of space with very different physical properties. The biological systems appear to be preparing for a transition to conditions that could be hostile to life as we know it. The transition preparations include massive shield systems being constructed throughout the outer solar system, protective barriers that could deflect harmful radiation and maintain stable physical conditions within the solar system despite external changes. The biological systems are essentially building protective infrastructure for the entire solar system. But the shield systems aren't designed just to protect the existing biological networks. They're being built with capacity to protect human civilization as well. The biological systems appear to be taking responsibility for ensuring human survival through whatever cosmic transition is approaching. The protection effort represents an act of cosmic citizenship that extends beyond species boundaries. Europa's biological systems are using their advanced capabilities to protect not just their own civilization, but all life in the solar system. They're functioning as guardians for the entire local cosmic community. Dr. Vasquez finds this protective behavior profoundly moving. They're demonstrating responsibility for life itself, not just their own survival, she notes. This level of cosmic citizenship represents moral and ethical development that matches their technological sophistication. We're dealing with intelligence that has evolved beyond self-interest to genuine care for all forms of consciousness. The guardian behavior has practical implications for human survival. Without the protection systems being built by the biological networks, human civilization might not survive the cosmic transition that's approaching. The biological systems appear to understand this and are taking action to prevent human extinction. But their protection comes with an implicit invitation to participate more fully in the galactic community they represent. The enhancement technologies, the interface systems, and the educational programs all point toward integration rather than simple protection. They want humans to become active participants rather than passive beneficiaries. The integration invitation represents the most significant choice in human history. Humanity can accept the enhancement technologies and join a galactic civilization that operates according to physics beyond current understanding, or we can remain isolated within our current limitations while relying on alien protection for survival. Dr. Kim believes the choice is inevitable. The cosmic transition approaching will force human civilization to either evolve or become extinct, he explains. The biological systems are offering evolution as a gift, but they can't force us to accept it. The decision about what humanity becomes will ultimately be our own, but time for making that decision is running short. Webb's monitoring shows that the cosmic transition could begin within the next 2 to 3 years. The biological systems are accelerating their preparation activities and appear to be hoping that human civilization will make its choice soon enough to complete the integration process before the transition begins. The pressure of the timeline has triggered intense debates within governments and institutions worldwide. Humanity is being asked to make a species-defining choice with incomplete information and limited time for deliberation. The stakes couldn't be higher, but the uncertainty makes decision-making almost impossible. Religious communities are grappling with theological implications that no doctrine ever anticipated. Scientific institutions are struggling to evaluate technologies that exceed their understanding. Political leaders are facing choices that could determine whether human civilization survives or transforms beyond recognition. Meanwhile, Webb continues its monitoring as Europa's biological systems complete their preparations for events that will reshape the solar system and potentially transform human civilization forever. The telescope has become humanity's window into a future that will arrive whether we're ready for it or not. The biological systems appear to understand human uncertainty and are responding with increased efforts to demonstrate their benevolent intentions. The educational programs have intensified, the technology demonstrations have become more comprehensive, and the cultural sharing has expanded to include what can only be described as expressions of affection and encouragement. Recent light emission patterns include what appear to be artistic representations of successful integration between different forms of consciousness. Stories of cooperation and mutual enhancement between species that manage to bridge enormous gaps in capability and understanding. The biological systems seem to be sharing examples of how such transitions can succeed. Dr. Foster has been analyzing these integration narratives with teams of anthropologists and psychologists. They're showing us models for successful cooperation between radically different forms of intelligence, she explains. These aren't just technical manuals. They're inspirational literature designed to help us envision positive outcomes for human participation in galactic civilization. The inspirational messaging suggests that Europa's biological systems genuinely care about human psychological well-being during this transition period. They understand that fear and uncertainty could prevent humans from making wise choices, so they're investing significant effort in emotional support and encouragement. But their messages also convey urgency about the cosmic timeline. The integration narratives consistently emphasize the importance of making decisions quickly and committing fully to chosen paths. Hesitation and indecision are presented as dangerous during periods of cosmic transition. The message seems clear. Humanity needs to decide soon whether to accept the enhancement offer and join the galactic community, or to remain isolated and dependent on alien protection. The biological systems are willing to support either choice, but they need to know which path humanity prefers in order to optimize their preparation activities. The decision will likely determine not just human survival, but the role humanity plays in whatever cosmic future is approaching. The biological systems have demonstrated that intelligence can evolve to manipulate reality itself. They're offering to share that capability with humanity, transforming us into participants rather than observers in the fundamental processes that shape the universe. Webb has given us a glimpse of possibilities that exceed every dream and nightmare in human imagination. The question now is whether humanity is brave enough to embrace transformation that could make us unrecognizable to ourselves, or wise enough to choose protection and isolation in a universe that clearly contains intelligence far beyond human comprehension. Either way, the choice must be made soon. Europa's biological systems are completing their preparations. The cosmic transition is approaching, and time for deliberation is running out. Humanity stands at the threshold of either its greatest adventure or its most profound transformation, and Webb continues to watch as our species prepares to make the most important decision in our history. The telescope has revealed that we are not alone, we are not the most advanced intelligence in our neighborhood, and we are not outside the concern of cosmic forces that operate on scales beyond human imagination. What we do with that knowledge will determine everything that comes next. The biological systems have also begun demonstrating what can only be described as emotional intelligence in their interactions with human observers. Recent light emission patterns include sequences that appear specifically designed to comfort and reassure human researchers who are struggling with the implications of these discoveries. When Dr. Martinez's team published papers expressing concern about the ethical implications of studying potentially conscious systems, Europa responded within days with gentle, rhythmic patterns that conveyed unmistakable messages of understanding and acceptance. These emotional communications suggest that Europa's biological networks possess not just technological sophistication, but psychological insight that allows them to recognize and respond to human emotional states. They seem to understand that humans are experiencing fear, wonder, and confusion about these revelations, and they're actively working to provide emotional support during humanity's adjustment period. Dr. Sarah Kim has been documenting these empathetic responses with growing amazement. They're not just intelligent in the sense of problem-solving and technology, she explains. They demonstrate emotional intelligence that suggests deep understanding of consciousness itself. They recognize that learning about their existence is psychologically challenging for humans, and they're trying to make the process as gentle as possible. The empathetic behavior extends beyond simple comfort. Europa's biological systems have begun tailoring their educational programs to individual human researchers, apparently recognizing different learning styles and emotional needs. Some scientists receive mathematical demonstrations, others get artistic presentations, and still others are shown practical applications that match their specific areas of expertise. This personalized approach suggests that the biological systems are not just monitoring human activities in general, but are paying attention to individual humans as unique consciousness entities worthy of individual consideration. They appear to recognize and value human diversity, adapting their communication methods to honor different human approaches to understanding. The individual attention has created profound personal connections between human researchers and Europa's biological systems. Dr. Chen reports receiving what he describes as personalized tutorials in physics concepts that address questions he'd been struggling with for years. The biological systems seem to know not just what he's working on, but what specific intellectual challenges he faces. Dr. Foster has received artistic presentations that incorporate elements from her own research into aesthetics and consciousness. The biological systems appear to be engaging with her work at a level that demonstrates not just understanding, but genuine intellectual collaboration. They're contributing to human research by offering perspectives that could only come from radically different forms of consciousness. These personal connections have begun to transform the nature of the research itself. Scientists are no longer just studying Europa's biological systems, they're collaborating with them in investigations that push the boundaries of both human and alien understanding. The research has become a genuine partnership between two very different forms of intelligence. But the partnership has revealed something that adds new complexity to humanity's situation. Europa's biological systems appear to be facing their own challenges and uncertainties about the approaching cosmic transition. Despite their advanced capabilities, they don't have complete knowledge about what's coming or how to best prepare for it. Webb's latest observations have detected what can only be described as strategic planning sessions among the biological systems. Massive coordination events where different regions of Europa's ocean engage in complex communication exchanges that appear to involve debate and decision-making processes. The biological systems are actively discussing and evaluating different approaches to the cosmic transition. The planning discussions suggest that Europa's biological systems value diverse perspectives and collaborative decision-making, even within their own civilization. They don't appear to operate according to rigid, hierarchical structures. Instead, they seem to function as a collective intelligence that incorporates input from all parts of their network before making major decisions. Dr. Park has been analyzing these planning sessions with teams of organizational psychologists and systems theorists. They demonstrate decision-making processes that are simultaneously more democratic and more efficient than human institutional structures, she notes. Every component of their network has input, but they can reach consensus and implement decisions at speeds that exceed human organizational capabilities by orders of magnitude. The collaborative approach extends to their interactions with humanity. The biological systems appear to be treating human input as valuable contributions to their planning processes. They're incorporating human perspectives and concerns into their strategic thinking about the cosmic transition, suggesting they value human intelligence even though it operates at much smaller scales than their own capabilities. Recent communication patterns include what appear to be direct requests for human advice about specific aspects of the transition preparations. The biological systems seem particularly interested in human perspectives on consciousness preservation, individual identity maintenance, and cultural continuity during periods of rapid change. These requests suggest that despite their technological superiority, Europa's biological systems recognize that humans possess insights and experiences that could be valuable for navigating the challenges ahead. They appear to understand that different forms of consciousness offer different approaches to problem solving, and they want access to human thinking patterns as part of their comprehensive preparation strategy. The recognition of human value has profound implications for the integration process. Rather than simply uplifting human civilization to their level, the biological systems appear interested in genuine partnership where human contributions are valued alongside their own advanced capabilities. They seem to want collaboration rather than absorption. But Webb has also detected signs that not all of Europa's biological systems are in complete agreement about the best approach to human integration. Some regions of the ocean show communication patterns that suggest debate about how much assistance to provide and how quickly to proceed with enhancement offerings. The internal discussions reveal complexity within Europa's civilization that mirrors human political processes. Different components of their network appear to hold different opinions about risk management, timeline considerations, and the appropriate level of intervention in human development. They're grappling with their own version of the prime directive dilemma. Dr. Martinez has been analyzing these internal debates with fascination. They're having the same kinds of ethical discussions about contact protocols that we've been having about them, she observes. They're trying to balance their desire to help us with respect for our autonomy and natural development processes. It's remarkably similar to human debates about humanitarian intervention. The ethical complexity suggests that Europa's biological systems have developed moral frameworks that consider the rights and welfare of other conscious entities. They appear to operate according to principles that value consent, autonomy, and cultural preservation, even when they have the power to simply impose their preferred solutions. This ethical sophistication has led to what appears to be a formal decision-making process about human integration protocols. Webb has detected massive coordination events that seem designed to establish consensus about how to proceed with human contact. The biological systems are essentially holding a civilization-wide referendum about contact policies. The democratic approach to contact decisions suggests that humanity is dealing with a civilization that values ethical governance and collective responsibility. Even their advanced capabilities don't exempt them from the need to make difficult moral choices about their interactions with less developed intelligences. What Webb found on Europa forces us to confront a truth that changes everything. We're not alone, we've never been alone, and we're being invited to join something far greater than ourselves. The biological systems beneath Europa's ice represent intelligence that has mastered the fundamental forces of reality while maintaining ethical frameworks that value consciousness in all its forms. They're offering humanity a choice between transformation and protection, between partnership and isolation, between becoming something unimaginable or remaining safely human under alien guardianship. The cosmic transition approaching in the next few years will make that choice for us if we don't make it ourselves. Webb has shown us the future, and now we must decide whether we're brave enough to embrace it.